Okay, last video we talked about drawing the general solution to the differential equation dy dx equals cosine of x. And if you remember, we agreed that the antiderivative was sine, but therefore the function was sine of x plus some constant value. I told you how to go ahead and put it into your calculator. So I've got an example here, and what I want to do now is I want to just look at the slopes of these solutions. So we're going to look at what is the slope at any given point. And let's start with the fact that we know that when x is equal to 0, regardless of what the constant value is, the slope of this graph will be 1. So let's look at some other points. Well, how about here? The slope of this graph at pi over 2 will always be equal to 0. And at negative pi over 2, the slope will be equal to 0. So what happens in between? Well, if we want to get into some sort of detail, we know that somewhere in here we'll have a slope of 1/2, something between 1 and 0. And over here we'll have a slope of 1/2, again, somewhere between negative pi over 2 and 0 in the x direction. We'll still have a slope of 1/2. And let's do one more. Over here somewhere, we're going to have a slope of negative 1/2. And over here, we're going to have that same slope of negative 1/2. So this drawing of the slopes themselves is actually called a slope field. And I have a poor example, which I'm about to show you. Okay, well, the good news is I have a better example of what I thought I was going to show you because I went ahead and changed emulators. And notice the similarities that this bears to the graph that we were just looking at. We have a slope of 1 right here. We have a slope of 1/2, and I'm just going to try to be consistent on colors. Slope of 1/2 at the gold. So right here, a slope of 1/2. And again, these are approximately, I'm just sort of saying probably about 1/2. We have a slope of 0 here, 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 and here, and here, and here, and here. And again, over here, slopes of 0. Trying to be as neat and tidy as possible. And then we had our negative half slopes over here and over here. So we know that this is a graph of sine. And what we can see is that if we look at this, what we call a slope field, we've got some possible solutions. We have a possible solution that looks like this. We have a possible solution that looks like this. We can, given a starting point, start somewhere, let's say at 2, 0. Let's say that we're starting here at, 0, 2. And if we look at the slope pictures, what we see is that this goes up. And then if we're tracing along with these slopes, it must come back down again, come down here. We're always just looking at sort of the next column of slopes and say, okay, well, where would this one go if it continued its pattern? And so this here is the graph of y equals sine of x plus 2. And that is the solution to dy dx equals cosine of x, given an initial value of 0, 2. So really the trick here is just matching up the slopes. So I'm going to stop this video now. You've now been introduced to the idea of a slope field, the idea that we've got all of these little slopes. We know what they are. Given an initial value, then we can put a point on the slope field and then sketch in what might the solution look like. And we'll come back with some differentials that are a little bit different than just a very simple, hey, we already knew the answer to this one, because we don't need a slope field to find the antiderivative of dy dx equals cosine. So we'll come back and we'll look at some more complicated slope fields in the next video. Thanks for watching.